Today, we're going to talk about a threat that's growing, but one that most cities, well, they're basically blind to it, at least with the tools they have right now. We're going to see this whole thing unfold through the eyes of a small but really ambitious town, Buellton, California. Think of them as a city at a crossroads between growth and risk. Honestly, their story is a preview of how pretty much any city can learn to see its own future. Okay, let's dive in. This quote just gets right to the heart of the problem. For decades, urban planning has relied on tools that are fundamentally frozen in time. They show us a snapshot of what was, but they're completely blind to the dynamic reality of a living, breathing city. And this isn't just some technical limitation. It's a strategic trap that a lot of cities, maybe even yours, are caught in right this second. All right, so here's our game plan for this explainer. We're going to kick things off by defining this invisible problem that cities are up against. Then we'll introduce the digital twin as the predictive solution. We'll get into how it thinks, what kind of data it needs to survive, and see how it's already out there protecting communities. And finally, we'll lay out a clear blueprint for how your city can do the exact same thing.
Right, Section 1, the invisible flood problem. This is all about getting to the bottom of why our current methods are, frankly, failing us in the face of modern climate change and all these new development pressures.
Really think about that for a second. We pour so much time and money into planning for that one massive catastrophic weather event. But what if the real danger is quieter? What if it's more like a death by 1,000 cuts, happening right under our noses, one permit at a time? So here's the crucial point. A city isn't static. For a town like Buellton, every new subdivision, every newly paved parking lot, every single rerouted drainage ditch, it all changes the city's relationship with water. Now, individually, these changes seem pretty minor, right? But when you add them all up, they create a brand new, totally undocumented flood risk that our old, static maps are completely blind to. And that brings us right to the solution, the predictive digital twin. So let's explore how this tech actually lets us see the consequences of our decisions before we make them. It's all about making the invisible visible. This slide just illustrates the paradigm shift perfectly. On the left, you've got the old way. Static, historical, always reactive. It's kind of like trying to navigate a highway by looking only in the rearview mirror. It's crazy. But then on the right, you have the digital twin, a living simulation that fuses real-time data together. It doesn't just show what is, it predicts what if. And that is the giant leap from reactive city management to proactive. Now, let's get super clear about what we mean by a digital twin. This is not just a pretty 3D model. Nope, it's a dynamic, data-connected environment. It's a virtual replica that's being constantly fed real-world information, which lets it mirror the current state of the physical city and, this is the important part, to simulate its future.
So what's really interesting here is the tangible power this gives you. You can literally watch how a single new high-rise is going to alter water runoff for an entire district. This is all made possible by amazing platforms like Cesium, which provides that real-world 3D geospatial foundation for the whole city, and NVIDIA Omniverse, which brings the powerful simulation engine to visualize all these complex physical interactions in real time.
Okay, so we have this powerful visual tool, but how does it actually think? How does it turn this massive sea of data into intelligence we can actually use? Well, this section is all about giving the twin a voice and a brain. The twin's logic is built around this proven decision-making framework. It's called the OODA loop. First, it observes. It's just ingesting data from every source imaginable. Then it orients, running simulations to understand what all that data actually means in context. Third, it decides, evaluating different options against the city's stated goals. And finally, it acts by generating these clear, data-driven recommendations for human experts to review and approve. It's this continuous cycle of sensing, understanding, and advising.
Now, for the twin to even reason about the city, it needs a kind of engineering logic, a grammar. And that's this form-function-behavior framework. So take a storm drain. Its form is the pipe's diameter and what it's made of. Its function is what it's supposed to do, carry, say, 50 cubic feet of water per second. But its simulated behavior might show that it actually overflows at just 35 CFS during a heavy storm. This framework is exactly how the twin understands that critical gap between how things were designed and how they perform in reality. Of course, this entire intelligence system is, well, it's worthless without the right fuel, and that fuel is data. High-quality, reliable, relevant data is the absolute non-negotiable foundation for any digital twin worth its salt. And that data comes in two basic flavors. You've got direct measurement, which is simple. A rain gauge tells you how much it rained. The data is the insight. But then there's indirect measurement, which is more complex. That's when you use raw data, like video from a traffic camera, and then apply an AI model to infer an insight, like traffic congestion. A really robust digital twin has to be a master of both. So how on earth do you build that super high-fidelity base model of the city? It's a really rigorous workflow that starts with mobile LiDAR surveying. First is planning, to figure out exactly what data you need. Then comes acquisition, capturing literally billions of precise 3D points. After that, you process all that data into one unified 3D cloud. And finally, you extract intelligent models. This whole workflow has to be precise, because at the end of the day, the accuracy of the twins' predictions depends entirely on the quality of this foundational 3D model. Look, I know this might all sound a bit futuristic, but I want to be really clear. This is not science fiction. This technology is being deployed right now on massive, real-world projects all over the globe. One of the key things that makes this all possible is an open standard called 3D tiles. This quote from the team at Unreal Engine just says it all. What YouTube did for streaming video, 3D tiles is doing for massive 3D datasets. It's a streaming technology that lets you interact with a model of an entire city in a web browser on pretty much any device without grinding to a halt. It's what makes this data truly accessible and, more importantly, usable. And that accessibility, it leads to some very, very tangible results. Let's talk return on investment for a second. This number, it's not a projection, it's a real result from a single project. Yup, $400 million. That was saved on the Bull Run water treatment program in the US. So how'd they do it? By giving project managers a digital twin to rehearse construction sequences, to catch design clashes before they happen out in the field, and to make proactive decisions. They basically went from reacting to expensive problems to preventing them entirely. And Bull Run is not an outlier. This tech is quickly becoming the global standard for managing complexity. We're seeing it at a national scale with projects like Virtual Singapore, in massive transit infrastructure like the UK's HS2 high-speed rail, and in smart construction initiatives all across Japan. It's really the new benchmark for any high-stakes project. So let's bring this all home. What does this mean for your city? What's the practical path forward? What's the blueprint that a city, just like Buellton, can use to become more resilient and predictive before the next storm hits? Here it is. This is the blueprint. First, you embrace predictive analytics. Start testing what-if scenarios instead of just reviewing static plans. Second, use the twin to create real data-driven accountability. Quantify the impact of every decision. Third, commit to that big operational shift from reactive to proactive management. And finally, you have to use the digital twin as the single source of truth that unites everybody, planners, engineers, and the public. These 4 pillars, they don't just improve efficiency, they fundamentally change how a city understands and manages its own future. And the results of making this shift, they're undeniable. Adopting a digital twin methodology drives down planning time, it dramatically cuts mitigation costs because you're solving problems before they're even built, and it reduces those costly project overruns that plague so many public works projects. The value is clear, it's measurable, and it's profound. So, we end right back where we started. Just like in Buellton, your city's future is being written every single day, in the quiet approval of a permit and in the fury of the next storm. So the question is, who's telling that story? Is it the old black and white maps that can't see what's coming? Or is it a living, learning digital twin that can help you write a completely new story, one of foresight, of resilience, and of intentional evolution?